Okay. I have here just a list of activities that are in this project. So I will not just review. I will not review all those projects. So generally, those activities are a good mix between the characterization, field methods, and modeling stuff. But today I'm just talk about the first activities, which is almost done. So it's my last chance to talk about it. So this project is related to aquifer characterization for the optimization of a pump and treat system to remove contamination in the ground. Just a minute. Try to move my. Okay. And just a little background. So it's a system that is operated by the province. It's installed in a very complex, we'll say, sediment, gravel, silt, and rock system. And the system, the problem with the system, it's pretty costly to operate because it pumps a lot of water, and it's estimated that like 90% of the water is fresh, it's clean water. So they would like to pump less clean water. So they would like to optimize the pump and treat system to lower the volume of water that is treated and we think that a better characterization of the heterogeneity could help to optimize the system. So for this project, we would develop a kind of a modern characterization program per se. So the objective are to quantify the hydraulic properties for each sediments that are present at the site. So it can be sand, gravel, silt, and rock. And maybe if they are present, to identify the main contaminant pathways in the system. So to make sure that we can capture it with the pump and treat system. So the characterization program is based on a method that we developed in the past at the GSC ENRS. So this method was developed to overcome the lack of field method to estimate the vertical permeability. So I won't go in detail in the technique, but it's essentially it's a method. It's a well-based method. So it's like two screens assembly where we induce an hydraulic stress in one of the screen, and we measure the hydraulic head response in the two screens. So those responses are used thereafter to analyze the hydraulic conductivity in the field. But so the challenge for the project was to acquire high quality, high resolution data for all material, and also in a reasonable amount of time, because we know that hydraulic tests in silt or less permeable units can take forever. So, for example, in silt, it can take 2 or 3 hours to get just one test. So you can spend your life in the field if you are not optimizing your system. And so for the project, we had several wells in sediment and rock, and also we have the pretty contrasting hydraulic properties between the sediments. So we have very compact silt, gravel, and silt. So the first one of the first thing for hydraulic testing is to have good wells. So especially in the sediment, because for this characterization program, we need to get a high resolution profile of the hydraulic conductivity. So we had to modify the wells installation, so to making sure that we can have the screen in direct contact with the sediment. So that was one of the main important components of the project. And also, we optimize the test assembly. So for each sediment, making sure that, in fact, try to find a trade-off between the test duration and the quality of the data. So each anticipated hydraulic properties value for each sediment types, we adjusted the test parameter, like the riser pipe diameter, the length of the stress interval or the middle packer, and make sure that for each sediment we will get the best result, and also we will not spend months on the field. So just an example of a criteria that we're used to for the optimization. So making sure that we can measure the heads in the observation interval in 1 and 2, making sure also that the heads are sensitive to each hydraulic properties, because if heads are not sensitive to vertical or horizontal hydraulic conductivity, it's not possible to estimate this property. So, and also finally the duration of the test, so we can play with the parameter to reduce the length of each test. So we end up with a kind of a program where we have for each kind of sediment different configuration of the testing interval. So just few results. So so at the end of the characterization program, we did like more than 250 hydraulic tests at the vertical resolution between half meter to 2 meters. So with those tests, we get, here we have a 4 example for wells where we get the profile for the hydraulic conductivity. The first thing that we can observe is that there's a large range of a large variation in permeability, almost 4 orders of magnitude. If you compare in the sand or the gravel versus the till, so it can be pretty contrasting. And another interesting thing is that we identify 2 high permeability pathway that can be potential migration way for the contamination. Those pathways are identified as a peak 1 and peak 2. So each of those wells are separated by more than 1.5 kilometers. So we can recognize those patterns all over the study area. And a final result. So with we made some statistics for each sediment, so we can have the hydraulic conductivity for each sediment, and also the anisotropy. So this information will be used in a model thereafter to model the flow and the transport, and for the optimization of the pumping rate of the pumping system. So in conclusion, so this project provided new insight about the migration, the pathway of contaminant, and we can't find the hydraulic properties for all kind of sediments. So and finally, this will improve. So we hope that will improve the security and the pumping system as well. This will lower the cost of operation. So that's it for me.